Okay, so this is my branch 1, branch 1, and let's say this is my branch 2.
Two.
So in branch 1, I am using IP address from this network 192.168.10.0/24 network. In branch 2, I am using IP address from this network 192.168.20.0/24 network. Between branch 1 edge router and ISP, I am using this network 100.1.1.0/30. Between branch 2 edge router and ISP, I am using this network. Hope it is
Okay.
clear.
Yeah, yeah,
Now,
clear now. Yeah.
between branches, I have created one tunnel, and on this tunnel, you can see here I am using IP 1.1.1. Here I am using IP 1.1.2. Done. So what will happen when this user, let's say ping this user, source IP address will be this one, destination IP
Mm-hmm.
address will be this one. Actually, source IP, let me copy it. Yes. So here, Bijay, if I will ping PC number, this PC3 from PC1. Let's say I am pinging PC, this PC from this
PC.
PC. Right?
Okay.
PC3 from PC number 1. So source IP address will be what here? Source IP will be 192.
Yeah, 192 dot.
192 dot
So you should assign one or
168 dot
sorry one.
10.1. Yes, here
Two.
I am running 1. This
Okay.
will be the source IP address, and destination IP address will be
Will be 192.168.20.1.
192.168.20.1.
Yeah.
Source MAC will be the MAC address of PC1, and
MAC
destination
address.
MAC will be the MAC address
MAC
of default
address.
gateway,
Default gateway. Correct.
right? After
Yeah.
that, this PC will forward this traffic, this packet to router 1. Yes or no? Now
Yes.
router 1 will check their routing table to forward traffic
Yeah.
in 192.168.20.1.
168.20.
That means in 20.0 network. Router 1 is going to
Yes.
check their routing table. In their routing table, this network will be available through tunnel interface. Like if I
Correct.
will talk about the routing table of router 1, so in the routing table of router 1, there will be this network 192.168.20.0/24,
20.1.
and reachable exit interface for this network will be tunnel 1.
Another one.
Tunnel 1. And whenever exit interface is tunnel interface, then router is going to add one extra
Yeah.
header at layer 3, that is called GRE header.
Yeah.
And
GRE
in
that
this
yes.
GRE header, router will provide again source IP address, destination IP address.
Destination
So
address
this
and
time source
again
IP address will be the
source I
IP address
111
of tunnel source.
tunnel source.
So
Yes.
here you will define what IP address as a tunnel source:
Yeah.
100.1.1.1, your
100.1
public
dot.
IP address. Your
Okay.
public IP address, this IP address.
Okay. Okay.
This IP address will be your tunnel source IP address, and this IP address will be your tunnel destination IP address.
Destination.
Right?
Sure.
So on router number 1, tunnel
Tunnel
source
source
is
is
100.1, and tunnel
100.1.1.1.
destination is 101.1.
Destination 101.1.
Right?
Yes. Correct.
So in the GRE header, source IP address will be what? Source IP address will be the tunnel source IP address. Tunnel source IP
1.1.
address is 100.1.1.1,
100.1.1.1.
and destination will be the tunnel destination IP address, that is
101.
101.1.1.1.
1.1.1.
Right?
Yes.
And then there
Yeah.
is one field called protocol field. So in the protocol
GRE
field,
header.
there will be protocol number of.
Protocol number.
Yeah, let me show you everything practically.
Sure, sure,
Okay.
sure.
So what I am going to do, I am going to take access of router 1 here. On this router, first of all, let me check the IP configuration. So IP interface brief. So you can see I have created one tunnel as well, and on that tunnel I am running IP 1.1.1 and my tunnel is up. On
Yeah.
physical interface you can see E3/0, which is my LAN interface where I am running IP 192.168.10.10. This one is also up. And
Yeah.
on public interface, outside interface, I am running this IP address 100.1.1.1.
Oh,
Okay. If you want
yes.
to check the tunnel interface configuration, so you can run command show run
So
interface
run
tunnel 1.
tunnel.
Tunnel 1. So here you can see tunnel source IP address is
Source address
100.1.1.1. Yes or no?
1.1.1. Yeah, correct.
And tunnel
Yeah,
destination
destination
is
is 101.
101.1.1.1.
Correct. Yeah,
Right?
both of them. Yes.
On the same in the same way, on router number 2 also you can verify the IP configuration. So IP
So
interface
IP
brief.
interface brief.
Tunnel 1 IP address is
Tunnel
1.1.2 and
1,
tunnel is up.
1.1.2, tunnel is up. Yeah.
Physical interface IP address, that means my LAN interface IP address is this one 20.10, and on my outside
20.10.
interface I am running this IP address.
Correct, correct. Yeah, yeah.
Right? So
Yes.
IP protocol, am I running any protocol over here? So yes, I am running EIGRP 100. I am going to
Yeah,
remove
yeah,
this
yeah.
configuration. Okay, actually I am running EIGRP so that we can share our private network through tunnel interface. You can see. So
Mm-hmm.
run section EIGRP. So in EIGRP I have run how many command? Router EIGRP
Only
100.
router EIP
After that
100.
network I have advertised the network which is running on tunnel interface and my private network. Yes or no?
Yeah.
So what will happen here? Here R1 will send one hello message from tunnel interface. This router
Yes.
will also send hello message from tunnel interface to form EIGRP neighborship.
Correct.
Yes or no? And on
Yes.
EIGRP neighborship will form, both are going to exchange their private network. Router 1 is going to share this network to router 2, and
To
router 2 is going to share this network to router
router 1.
1.
Router.
And
Yeah.
whenever router will receive the private network information from their neighbor, exit interface for that network will be tunnel interface. Yes or no? See here, on router number 1, if I am running command show IP route
Mm-hmm.
192.168.20.0, exit interface is what? Next hop IP address is 1.1.1.2. Exit
Correct.
interface is tunnel 1 interface, and
Tunnel
as
1
I told you, whenever exit interface will be tunnel interface, router is going to encapsulate one header. Router is going to encapsulate actual ICMP traffic with GRE header.
GRE header.
So
Yeah.
now I am going to actually capturing the link of F0/0 on router number 1. Let me capture this link so that I can show you the data. Which link?
Sure.
F0/0.
F0/0. Yes.
I have captured this link, and now I am going to ping the remote site user from site 1, from branch 1. So let me take access of PC1. On this PC, first of all I need to configure IP. IP is 192.168.10.1/24, and gateway is 192.168.10.10 is my gateway.
In that
Then in the same way I have to configure IP on PC3 also. Here also I am going to say IP
IP.
192.168.20.1/24, and gateway is 192.168.20.10. Done. I have
Okay.
configured IP address on both PC1 and PC3.
PC.
Now I
Okay.
have capturing here Here
Yeah.
you can see I have capturing.
Okay.
See the hello messages of EIGRP. Router 1 is sending hello message. Source IP address is 1.1.1.1. Tunnel interface IP address
Tunnel
and
interface
destination is
IP address standard.
multicast.
Multicast
And then again you can see
24.0.0.
there are
Okay.
two IP header. One is this one and one is this one. And between
Correct.
both IP header
This
there
one
is
to
GRE.
GR.
GRE header. Yes or no?
Yeah. Source and destination.
Source and
GRE. Correct.
destination. So if I will ping
From PC1 to PC3.
PC3,
Yeah.
ping 192.168.20.1.
20.1.
Done.
Yeah.
Okay, router 1 will check what? Their routing table.
The routing
So in
table
their
is
routing table, so IP route. This network is available through tunnel interface. So it is going to forward traffic on tunnel interface. And whenever exit interface is tunnel interface, router will add one extra
on
IP
GRE
header.
header.
So see
Yes.
the ICMP request message here. How many IP header are there? Two IP header.
To
One is this one where source IP address is 192.168.10.1, destination IP is
20.1.
192.168.20.1. Which PC will generate? Which PC
SCMP
have generate
request.
ICMP request? Yes or no?
Correct.
After that, see the GRE header. Because
Yeah.
exit interface is tunnel interface. In the GRE header, there is nothing, but there is one information about
GRE header.
IPv4. That
IPv4. Okay.
upper layer is IPv4 protocol. This is actually type code of IPv4 protocol.
Oh, okay. Okay.
This one is type code of IP protocol, IPv4 protocol.
Version 4. Okay. Version 6, which one will come? Like, what is that protocol? Like,
No, when version 6 will come up, that time I will show you. I will discuss version
okay.
6 as well, right? Now
Okay.
you
Okay.
we have only 5 to 6 classes left.
Sure. Sure.
So once
Okay.
we'll finish VPN, we will discuss IPv6 as well. Okay?
Sure. Sure. Sure.
This one is my actual ICMP request message. Yes or no? This one is my
Yeah.
actual ICMP request message.
Request
See,
message.
after that, this is my actual IP header. Here source is 10.1, destination is 20.1.
Destination 20.1. Yeah.
Here protocol field value is what? 1. That means upper
1.
layer traffic is of ICMP. But after that, between now router should add what? Ethernet header. But between Ethernet header and your actual ICMP header, there is one header called GRE header. And in the GRE header, there is information of only IP protocol. And after that,
Yeah.
if you will open this IP header, the outer IP header, what
The
you will see?
how is the flow? Is it top to bottom or bottom to top?
Yeah,
Or this flow of
bottom to top.
traffic?
First, it will check Ethernet header, then it will check what?
Internet header.
This IP
Yeah,
header.
directly the source to destination. Then this
Yeah,
order, no, that from top to bottom.
exactly.
Okay. Okay.
Right.
Okay.
Then in this IP header, you can see source IP is tunnel source IP address and destination is tunnel destination IP address.
Okay.
And who have a hand over the actual packet means upper layer protocol is what? GRE. Generic routing encapsulation, and protocol number of GRE is 47.
47. Okay.
Getting
GRE
my
is
point?
47.
Means
Yeah.
what is happening on router number 1? Here is my router 1. This is ISP. This is router 2. Here is user 192.168.10.1. Here is user 192.168.20.1.
20.1.
Right?
Yeah.
Here IP address is 100.1. Here IP address is 100.2. Here IP address is 101.2. Here IP address is 100.1. And between router 1 and router 2, I have created one tunnel. And on the tunnel interface, IP address is 1.1.1. Remote tunnel IP address is 1.1.1.2,
1.02.
right? So when
Yeah.
this user is pinging to this user, actually machine will generate what? ICMP traffic.
ICMP request. Yeah.
ICMP, your
MP.
ICMP, actual ICMP traffic is there. After that, IP protocol will add IP header. Source IP is 192.168.10.1. Destination IP is 192.168.20.1. And there is one field called protocol field. In protocol field value is 1, because ICMP protocols hand over this actual traffic to IP protocol, right?
Okay.
Now when router 1 will receive it, router 1 is going to check the routing table, and router 1 will found exit interface is tunnel interface. So
Tunnel
whenever
interface.
exit interface is tunnel interface, it is going to add what? GRE header.
One GRE header.
GRE header.
Header.
And in the GRE header there will be information about
The
IP
tunnel
protocol,
IP protocol.
that after GRE which protocol is running. So there will be protocol number of GR, type code of IPv4 address, that is 0x800. This is type code of IPv4 address.
Okay.
Done. And now GRE will add one more IP header over here, and in this IP header source IP address will be tunnel source IP address, that is 100.1.1.1, and destination is 101.1.1.1. So when ISP will check it, ISP will open which header? This header or this header? Upper header? Outer header?
Yeah.
So ISP will check what? Destination is 101.1.1.1. So
101.
ISP will forward it towards router number 2. ISP will never check this header, yes or no? If ISP will
Okay.
check this header, then destination is private. ISP will drop it.
Correct.
And that is the reason why PCs are able to communicate with each other through tunnel.
Tunnel. Oh, okay. Okay.
Right? Because in the outer IP header, source and destination IP address are public IP address. Getting my
Okay.
point?
Yes.
Let me explain you again here. See what is happening. Just give me 1 second, Vijay.
Yeah, actually, I am clear this point. I need only that the GRE, the IP you told, no, the GRE header. In that
Yes.
GRE, the GRE header, what steps are running? Can you tell me again once again if you don't mind?
Here you can see this is actual packet. In this
Yeah,
protocol
correct.
field number will be 1. After
One.
that,
Yeah.
GRE is going to add one GRE header over here.
The protocol one means which one? That this
Protocol number
protocol
of 1 is
one.
ICMP,
ICMP. Okay. Okay. Fine.
right?
Yes. Yes. Okay.
After that, GRE header. Inside the GRE header, there will be
GRE header.
only information of IPv4
IP address.
protocol.
Okay.
That
Fine.
upper
Okay.
letter
Clear.
is
Yeah.
IP protocol. And
Yeah.
after that, in new IP header, source IP address will be the tunnel source IP address, destination will be tunnel destination IP address.
Sure. Okay.
And here, protocol field, in the protocol field, protocol number will be of GRE, that is 47.
47. Okay.
Done. So when
Yeah.
ISP will actually receive it, ISP is going to check this header, yes or no? So
Correct.
it will check destination. Destination is 100.
One.
1.1.1.1. Okay,
1.
101.1.1 is connected on this link, so it will forward it from here. When router 2 will receive it, router 2 will check what first? Destination. So
Yeah.
destination is
Destination.
okay, 100 101.1.1. This is my IP address. Let me check protocol field. It will check protocol field. So there is protocol number of GRE. So router 2 will
GRE
hand over
protocol.
it to GRE protocol.
GRE protocol. Yeah. Correct. I understood. Yeah.
Now GRE protocol will check what? Protocol number, type
Protocol
field.
number
In the
or
type
type
field,
field.
there
Yeah.
will be information of IPv4. So it is going to hand over this actual ICMP protocol to IP protocol. Now IP protocol will check destination. So destination is 192.168.20.1. Oh, 192.168.20.20 network is connected on this link. So it will forward it from here. Yes or no? So
Correct.
according to
Yes.
ISP, actually ISP will check upper IP header, and your
right,
edge
right, right.
router will check lower header, right? And
Okay.
this is how both branches are going to communicate with each other. Now is it clear?
Yeah, I am clear. Yes.
Yes. So see,
Yeah.
there is only one Ethernet header, but there is
Mm.
two IP header, and that is the reason why I'm able to see ping. I'm able to ping as well, yes or no?
Yeah, yeah.
And while
Obviously. Yeah.
discussing EIGRP, as I told you that we are still using EIGRP protocols on the tunnel interface.
Okay.
Here we are running EIGRP, right?
Yes.
Between router 1 and router 2 to share the private network information with each other.
Okay. But
Done.
it's not required, no. But we are not. But
See,
without EAGRPA, we can
without EIGRP, how you can share this network
network.
information?
Okay. So we need one protocol.
Or you can configure static routing. Okay, let me
Hmm.
disable EIGRP. Say no router EIGRP 100. I have removed the EIGRP configuration from here. Let me remove
Okay.
from router number 2 also.
Okay, I got it now. Because in the EIGRP only you enable, so that means this protocol through only you are enable communicate between both sides.
Yeah, exactly. And
Okay, okay,
so
okay, got it.
IP EIGRP neighbor. Now you can see
Or
EIGRP
else
is
we
not
need to
configured.
route static manually. We need to route.
Yes, exactly.
Okay.
Now I am not running any routing protocol over here. So tunnel interface is here. I am able to ping my tunnel interface. Ping 1.1.1.2, right? But so
Yeah.
IP route. Now 20 network is not available. 192.168.20.0 is not available in the routing table of router 1. How router 1 can forward traffic towards 20 network? Is it possible?
No,
No.
there is no. Yeah.
So now
We
it
need
will
to
not
add.
work. Now
Correct.
communication will not happen because it will forward traffic towards ISP because there is one default route, but it will not perform
Yes.
encapsulation, right? So
Correct.
ISP will drop it because source IP address is private,
Yes.
right? Now in this
Correct.
scenario, either you can configure what is static routing. So let's see, if you want to configure a static routing, you can configure IP route 192.168.20.0, 255.255.255.0, and exit interface will be your tunnel 1. Done. Like this also you can configure a static routing
Okay.
also. On router
Okay.
number 2, you need to configure 10 network IP route 192.168.10.0, and exit interface is tunnel 1.
No.
Always keep in mind, whenever exit interface will be the tunnel interface, GRE protocol is going to encapsulate GRE header.
GRE header. Okay.
Done. This is the concept only in point-to-point VPN. This is
Sure.
point-to-point VPN. We called it
Okay.
point-to-point VPN.
Point to
We
point
called
VPN.
it GRE tunnel.
GRE
We
tunnel.
called it VPN between two sites.
Sure.
So IP route. Now you can see a static routing. Through a static routing network is available. So still it can ping. PC1 can ping. See, it's working. But can PC1 ping 8.8.8, brother?
No.
Why? It's working. That means I have configured
Working.
netting as
Yeah.
well.
Okay.
That means
You already
on router
added
number
natting.
1,
Okay.
yes, NAT is also enabled.
Enabled. Okay.
So
So this
run,
topology, so many protocols running. That means natting concept also you can take,
yeah.
or this
And here you
VPN.
can
Yes,
verify
yes, yes,
also.
yes, yes. Yeah, that's good. The
Done.
same topology I will make it my UNG.
Yeah.
Sure.
So NAT is also configured. That's why PCs are able to ping
That's the reason.
8.8.8 also. And both branches are also able to communicate with each other.
Correct, correct.
right?
Without tunnel, we cannot communicate. With
We
tunnel
cannot
only, we
communicate.
can, yes, with
But
tunnel
on
only, we
the
can
tunnel,
communicate.
yes, but on the link you can see your traffic is in plain text. Yes or no? Traffic is still
Mm,
not secure. Yes or no? Anyone can read your data source IP address, destination IP address.
correct,
Everything is
correct, correct,
visible.
correct. Yeah.
Yes or
So
no?
this is not encryption. No? Correct.
Yeah. So to encrypt the traffic on the tunnel, we have IPsec. We have concept of
Okay.
IPsec. This is part
IPsec.
of security.
Sure.
Now, can you give me just 1 minute?